All right, everybody. So I'm going to do a real quick video about joints for you. There's not a whole lot of material for joints, but what I'm going to do is I'm going to help you figure out how to make a concept map. Okay. Concept maps are really great because you can put a lot of information. So a lot of information from one PowerPoint can go into like one chart, and then you can look at that one chart and understand how everything works together. I'm also going to show you how to label all the parts of the synovial joint, just in case you're a little bit confused about what I'm pointing to at different locations on the images. You want to think about the health of a joint, what things are necessary to make sure that a joint is nice and stable, but also movable at the same time. And then I would recommend after doing this and while you're studying, look over all those actions that we did in class and then try to understand what those actions are at different parts of your body. So like your arms and your legs. How do you abduct and adduct them? How do you do flexion and extension? What about rotation? Maybe think about some different workout activities that help you understand those actions, like, flexion of the knee. You would probably do maybe sit-ups, not sit-ups, squats or sit-ups, crunches. Those are going to be flexion and extension. So think about that in an application way. Okay. But we're going to get started by making concept map. So you notice I don't have anything here because I'm going to make my concept map from scratch, basically. A concept map should be a flow of information that all kind of goes together. So you can do this with embryology. You can also do this with joints. You can do this with tissues. You can do this in a lot of different ways in anatomy and physiology courses. So at the top of my concept map, I'm just going to put joints. And I'm going to make my handwriting not so bad. Handwriting is not that bad, but my little tablet here sometimes makes it look worse. So we're gonna have joints. So we're gonna have joints based on the type of tissue that holds two bones together. And that's what my map is going to refer to. Okay. So what we're going to see is that there are three types of joints, right? There are three types of joints based off of the different types of tissues that hold the joints together. So the first type is fibrous. There are going to be three types of fibrous joints. So we're going to have sutures. So now I know that fibrous joints are going to have my dense connective tissue, either really long or really short collagen fibers. And then there's going to be three types. Sutures, agomphosis, or a synchondrosis. I'm sorry, syndesmosis. Like that. So that means I have to have dense connective tissue for each of these. For sutures, this is going to be really small connective tissue, small dense connective tissue that goes between two bones. So this is going to be like short fibers. We're just going to say fibers. We'll make it easier. Then you can draw a bone, you can draw another bone like that. But that's not what I wanted to do. And I'm going to use blue as my dense connective tissue that's going to go between my two joints. Then I could just draw a gomphosis. So gomphosis is going to be a tooth. So there's my tooth that sits in the bone that makes up my upper and my lower jaw. And again, I'm going to have really short or small fibers that basically go from the tooth to the jaw. So again, we're going to say short fibers here. And now you see the difference between the suture and the gomphosis. The suture is not going to be part of the tooth, whereas the gomphosis will be part of the tooth. For the syndesmosis, this is going to be either medium or long fibers. And so for this one, I probably have to draw a little bit to the side, and I'm going to draw like what would be kind of a tibia Kind of goes like that. And then my fibula is going to kind of come down like this a little bit. And we're going to see that there's going to be longer fibers that go between those two bones, and that's a syndesmosis. So you see how I have like DES right there, and then I have DES here for my dense connective tissue. I'll put movements on at the end when I get through my whole entire concept map. So the next group is going to be cartilaginous. And we could just say cartilage, because cartilaginous is a little bit harder to spell. So these are going to be our cartilage joints. And there are two types of cartilage joints. So one is going to be a synchondrosis. And the other one is going to be a symphysis. Okay. So the synchondrosis, we're going to use hyaline cartilage that goes between two bones. For the symphysis, we are going to use fibrocartilage that goes between two bones. So you can think about a synchondrosis. Remember, chondro meant cartilage. You think about chondro means hyaline cartilage here. And I'm just going to draw like a long bone. This is probably the easiest one to think about. There's like my long bone with my epiphysis and my diaphysis. And I usually use purple for my cartilage. And there I see my synchondrosis. Or even the cartilage, technically, that's part of the articular cartilage is going to be a synchondrosis as well. For symphysis, what you might want to draw is you have like your vertebra. This is the anterior side of the vertebra. And then, whoops, pick a different color so that you know that it's not the same exact thing. Like you could pick a dark blue. In this case, I'm just going to make it yellow or orange so that I know my fibrocartilage is a different type of tissue than my hyaline cartilage. And that creates my symphysis right there. So that will be my intervertebral discs. The last one is a synovial joint. So here for cartilages, you could put cartilage, but it says cartilage already. So we're going to do synovial. Okay, a synovial joint has to have fluid between the two bones. It has to have a synovial cavity and synovial fluid. Synovial joints are going to have four distinct features. So they're actually not, there are many different synovial joints, but they're not different types of synovial joints. All synovial joints are going to have four distinct features that you need to know and be able to understand as part of a synovial joint. You can draw this out. You can also label it here. I'll draw it out and label the other picture as well. So to draw this out, probably need a little bit bigger space, but we're going to go with that. We're going to draw one side of a bone that's got a little bit of a rounded area, and then I usually draw my other part as a little bit more flatter area. I kind of think about this as like where the knee joint is. There's my tibia and my fibula. And of course, my femur could be a little bit bigger, but we're going to go with that. Okay. So the first thing you need is a synovial cavity with synovial fluid. But in order to create that, you have to have an articular capsule. So if I'm going to create a cavity that goes between these two bones, I have to create a boundary, basically. And that's what my articular capsule is going to be. I'm going to see that there's going to be ligaments. And I'm going to make this in blue because it's the same dense connective tissue that goes between one bone and the other bone. So I'm going to have a fibrous layer to my capsule made out of dense connective tissue. And as soon as we put our dense connective tissue over those two bones, we can see we already create a pocket. And then the deeper part of this pocket, which maybe I'll make a lighter green color so it's more distinguished. Yeah, there, you can see it a little bit better. The lighter green color is also part of the articular capsule, and that's the synovial membrane. So if you want to, you could label like this as number 1. This is our articular capsule. And then you have like 1A, and then there's 1B. And on your lecture, I just called this number 2 instead of number 1. Number 1 is the fibrous layer. And that is ligaments. Number 1A is the fibrous layer of ligaments, and number 1B is the synovial membrane. Okay, so as you create number 1, the articular capsule, what you're going to see is that number 2 is created as a result, and that is our synovial cavity filled with synovial fluid. Number 3, we're going to need some cartilage. Okay, so number 3 is going to be the hyaline cartilage that covers the epiphyses of our long bones here. That is our articular cartilage. So that's going to be number 3. Remember, we still want to have a little bit of a smooth surface for the bones to rub up against each other. There is fluid there. There's not a whole lot of fluid there. I just draw it really kind of separate from each other. But remember, the epiphysis of all bones, really where joints come together for all bones, you have a synchondrosis made of hyaline cartilage, and that's your articular cartilage. The last one is going to be a little harder for me to draw because I labeled a couple of things already. And I'm going to make it in, I'm trying to decide what color I want to do. I'll do like kind of a navy color here. So you can see there's 3 different colors. So we're going to put extra ligaments on the outside. So outside of the articular capsule, we're going to put extra reinforcing ligaments, just kind of like that. You can also have internal ligaments as well. So this is going to be my number 4. My number 4 is additional ligaments. So remember, those can be extrinsic, which means outside, or intrinsic, which means inside. You don't necessarily have to have the inside ones and the outside ones. That will depend on the joint. So like the knee joint has intrinsic reinforcing ligaments. This is what the ACL is and the PCL. It also has some extrinsic reinforcing ligaments, which is your medial and lateral collateral ligaments. Sometimes they're referred to as the tibial and the fibular collateral ligaments. But they're extra ligaments that go around the articular capsule to reinforce the bone so that it stabilizes it and makes sure that it doesn't do like hyper movement. So hyperextension, hyperflexion, or hyperrotation. Okay. So if you don't want to draw it, but I recommend you draw it, then you can also use this picture and you can go through and do some quick labeling. So what we're going to see is these 2 layers here make up number 1. And I'm not going to label it with all the words. I want you guys to do that. So that's 1A, and that's my 1B. And that creates number 2, which could have an A and a B, because 2A could be the synovial cavity and 2B could be the synovial fluid. Then you have 3. Remember, 3 is going to be our articular cartilage. And then you can see that this thing is number 4. That's our reinforcing ligament on the outside. In this image, they really just didn't put the reinforcing ligament on the other side. I don't know why. probably because the publisher's image actually had labels on the other side instead of on this side. Okay. So those are joints. You can see you can make a nice concept map where you put basically, I don't know, 5, 6 PowerPoint slides on one chart. And then let's do really quick too, I almost forgot the movement things, which is, remember there's 3 types of movements for joints. So we have a synarthrosis, synarthroses, amphiarthroses, and diarthroses. Okay, so these movements will correspond to these joints based on tissue type. This is a much harder concept to grasp because it varies a lot. But you can come in and you can see where the diarthroses are going to be. So synovial joints are diarthroses. You have to know that one. Cartilage joints, this is variable. It depends. If you're articular cartilage, you're probably part of a synovial joint, so you're diarthroses. If you're an epiphyseal plate, you're completely immovable, so you're a synarthroses. Maybe you're amphiarthroses if you're the cartilage that goes between the ribs and the sternum. So this one can be all 3. That's why it's difficult for me to ask you questions based on that. Let's look at the symphyses. So you either have the pubic symphysis or you have the intervertebral discs. How much movement you have here sort of varies a little bit. I mean, can you say they're completely immovable? No. Are they fully movable? No. So in most cases, these are going to be amphiarthrotic. But again, that's a harder concept to understand if you don't know where these joints are in the body and their movements yet. You can't really relate that back to being amphiarthrosis. That's why you have to know diarthroses are synovial joints. Synovial joints are diarthrotic. For sutures, sutures are primarily only found in the skull, and these ones are completely immovable. There is no movement or should be no movement, but this varies a little bit because after birth, there's still some slight movement between the sutures. Sorry about my lights going off. And then they become completely immovable. So if we're just talking about the adult, then we can just say that these are synarthrotic. For the gomphosis, if this is my tooth, if you didn't understand my drawing, so the gomphoses are going to be slightly movable. Just think about when you get braces, the whole point of how braces work is your teeth can move a little bit, but they shouldn't move a lot. I don't want to be some weird horror movie creature where my teeth spin. Like, I don't want to be that. I want them to move a little bit and shift a little bit if necessary, but it shouldn't be necessary. And then the syndesmoses, these ones are going to vary also. They can either be synarthrosis or an amphiarthrosis. They're not diarthrotic. Most of them are not fully movable in any way. And I wouldn't expect you to know which ones are synarthroses and which ones are amphi, because again, that's really complicated. That's why I like you guys to know synovial joints are diarthrotic, but the other ones, I won't ask you about their movements. If you're curious, now you have a whole concept map with all of that. See, this is how concept maps can help you in this class. You basically have one concept map for almost this entire lecture. The only thing we didn't do in the video for the concept map was the actions. That's something I want you guys to do at home on your own. look up some different, workout activities. Like I said, is that flexion extension, abduction adduction, protraction retraction. It'll help you when we get to muscles too. I'll try to bring up some activities, some like exercise routines that'll help you move specific muscles. But sometimes that's actually very difficult. Not sometimes, all the time, because multiple muscles are needed for actions. So I hope that helped you understand how to build a concept map. And going forward, I would like you each to think about how you're going to build your own concept maps in this class. It'll be very beneficial to you if you create your own maps, your own examples, and you think about stuff in your own way.